Welcome to the first R module. In this video, we'll be going over the solutions to the first R exercise. If you prefer, there's also a written version of these solutions on the class website. Now, this first R exercise was really designed to get you to explore the different options in Deducer. So if you found yourself struggling a little bit, don't worry. It's going to get easier from here. So the first step is actually not question 1. The first thing we need to do is open up Deducer. So to do that, I'm going to click this shortcut. And there are two windows here. There's the console window on the left and the data viewer window on the right. In order to open up my data, which is provided to you as an Excel file on the class website, I'm going to click on the Open Data icon on the data viewer window on the right-hand side of the screen. This will allow you to navigate to wherever you have that Excel file saved. In my case, it happens to be on the desktop. And I'm going to select it and open it. Because our data is only on one worksheet, the first one, I'm just going to click OK here. And I see that Deducer was able to load in the data correctly. I'm going to scroll to the right, make sure everything is there. Good. I'm going to scroll down to make sure I have 50 rows. Great. So at this point, we are now ready to start the exercise. The first question reads that varsity, the variable varsity, is currently stored as type double. We want to change this continuous variable to a categorical variable. R denotes categorical variables as factors. The way we're going to do this is using the data viewer window on the right-hand side. I'm going to click on variable view here, which will list all the variables in a column along with their type and something called factor levels. And so I'm going to go to varsity, click on type, and then select factor. Now notice when I do this that the factor levels column gets populated for that variable. It shows two factor levels, level 0 and level 1. And that's because varsity only has two values in it. I do want to caution you that when you're doing variable conversions in Deducer like I did just now, that you don't go back and forth too many times, because Deducer will make assumptions about what types of variables you want and what you want certain values to be. So just be aware that Deducer makes certain assumptions, and to always check your data after changing anything. For question 2, we want to sort two different variables, varsity and writing love, in different orders. So first we want to sort varsity in ascending order, and then writing love in descending order. Okay, so the way I'm going to do that, I'm going to click back to data view for now. The way I'm going to do this is by going now to the console window on the left-hand side here, and then clicking on data, then sort. This brings up a new window, the sort data frame. And what this allows us to do is sort data in either ascending or descending order. So I'm going to click on varsity and then move it over, and then also move over writing love. You can also just drag these variables over. And varsity is in ascending order, or increasing here, and that's what we want. But we want writing love in decreasing order. So what I'm going to do is highlight writing love and then click the button on the left here, and that will change writing love to decreasing, as you see. Now before I hit OK, it's important to visualize what's going to happen. So we know varsity only has two levels, right, or two different values, 0 and 1. And so what this is going to do is organize varsity such that all the zeros are on top and the ones are all on the bottom. And then for each category, so within all the rows for which varsity is 0, writing love is going to be organized in descending order, in decreasing order. And then again, for rows that have a varsity value of 1, writing love is once again going to be ordered in decreasing value. So we should see a jump in writing love, in the values of writing love, when varsity changes from 0 to 1. Okay, so I'm going to hit OK, and we'll see if that actually happens. Great. So the data changed here. We see varsity. So as you can see here, all the zeros were grouped together, and all the ones were grouped together for the varsity variable. And all the zeros were put first because we wanted varsity in ascending order. We wanted to go from 0 to 1. And the other thing I want you to notice is that the row numbers on the left-hand side here are all jumbled up because the original row numbers stuck with each row as it was sorted by R. So then let's keep that in mind, that varsity switches from 0 to 1 between ID 31 and 30 here, and then go look at what happened to writing love. So I'm going to scroll to the right, and we see that writing love is sorted in descending order until we hit between row 31 and 30 here, where it goes from 20 to 19 to 10, and then there's 2 cells with missing values denoted as NA. And then we start over again at 98, and then again, writing love is sorted in descending value. So I'd like to talk a little bit about missing values in R. So note that missing values are denoted as NA. The important distinction here between R and other statistical programming packages like, for example, SAS or Stata, or SPSS, whatever you might use, is that NA is not given a value in R. In those other packages, missing values are given either a very, very, very large positive value or a very, very, very large negative value. And there are reasons for this, but it's important to know that in R, missing is just missing, and it's not given a large value. Moving on to question 3. Question 3 reads, filter the data such that you create a data set with only records of students who have math love scores greater than or equal to 70. And so what we're going to do is go to the console window, go to data, and then select subset. What this is going to allow us to do is to create an expression that selects only for those students. So first I'm going to double click on math love, and when I do that you'll see math love populate the subset expression box. And then we have all these logical operators over here. And we're going to want to select the greater than or equal to button for greater than or equal to 70. And then we can simply type in 70 and hit OK. So what did this do? It essentially created a new data set for students or IDs that satisfied that condition. If we go to the data viewer window now on the right hand side, and under data set we click the drop down menu, we see that there are 2 options now, mock class data, which was our original data set, and now mock class data.sub. And selecting that second data set, we see that it's a truncated version of our original data set. And if we scroll over to the right, we notice that all the values for math love are greater than or equal to 70. Question 4 reads, click on extras, extras then data summary, for a quick summary of all the variables in your data set. How many missing values does Carter have? Okay, so I'm going to go back to our original data set, mock class data, and then I'm going to follow the instructions and go to extras. Actually, extras is not an option on the console window right now. So this is actually a good example of something you might encounter. The way to deal with this is to click on Packages and Data, click on Package Manager, and then select Deducer Extras here. Now if you follow the instructions in the installation video, these should already be selected. Okay, now that we do that, we see that extras pops up here in the console window. So that'll allow us to select data summary, and then it'll allow us to select our data set. I'll hit run. Now if I spread this out a little bit, makes a little more sense, and we can see that it gives us summary information for all the variables in our data set. Now, to specifically answer the question about how many missing values we have in the variable Carter, I go to find Carter. I go to that, and then I look at NAs, or number of missings, in other words. And I see that we have 12 missing values in the variable Carter. The next question asks us to create a histogram in dark blue for the variable coffee. And so what I'm going to do is go to Plots, and then select Plot Builder. I'm going to click on histogram and actually drag it down to this space right here. I'm going to let go. And then again, I'm going to click on coffee and drag it to the variable window. And once you drag the variable coffee over, variable will turn green. I'll hit OK. And this is going to plot a histogram of coffee drinking. Now, I want this histogram to be in blue. And this template that it offered me didn't offer me that choice. So what I'm going to do is delete this for now, and then select the Geometric Elements tab. And then I'm going to select Histogram from here. Now this is going to offer me a few more options, as you can see. I'm going to drag coffee over again under X. This represents the variable you want across the X-axis. You'll see that X turned green once I did that. And then this option allows me to set the fill and the color. Color just means the color of the line. So I'm going to click on color and then select some kind of blue. Hit OK. And I'll do the same thing for color. And then I'll hit OK. And then you'll see that it now plots me a histogram of coffee drinking in blue. Moving on. Now we want to create a scatter plot of hours of exercise, or in other words, a variable exercise, versus hours of homework. One reason you might want to do this is to see what the distribution is for people, or rather with what happens to the amount of time you spend exercising as the amount of time you spend on homework increases, right? So you can imagine if that was your question, this might be a first step into looking at that relationship. So what I'm going to do is first let me X out of this plot builder. I'm going to go to plot builder again, plots plot builder, and then from templates I'm going to select scatter smooth. So again, what I'm going to do is simply click here and drag this down into this space. Okay, and I have two options here. I can drag a variable onto the X and onto the Y, and as you probably guessed, that means that I can specify what variables I want on what axis. For this question, it doesn't really matter. I'm just going to move exercise to the X-axis and homework to the Y-axis. The question specifies that they want a smoothed curve, so I'm just going to leave that there, and I'm going to hit OK. Great, and so now we see this relationship. So as you can see here, the trend line is pretty flat. I wouldn't say there's a really dramatic trend at all. There might be a slight trend or small correlation between having a lot of homework and exercising less. But again, that would be a very weak effect here. And I don't notice any egregious outliers as well. So these are all things you sort of want to keep in mind as you look at these different plots. Moving on to question 7. Question 7 is asking us to create a histogram for the variable milk. And then it gives us a little more information, so let's just do that first. So I'm going to go to Plots and Plot Builder again. Drag down histogram, drag over milk. Whoops. Hit OK. Now I see this histogram for milk. I'm going to continue reading the question now. So the question says, you notice that there's one person who indicated 50, which seems like an outlier compared to the rest of your data. After going back to the data collection forms, you verify, in fact, that 50 was miscoded, and that the true value should have been 5. This happens all the time. You decide to fix this problem by creating a new variable called milkFixed. And so presumably now that's our exercise, to create a milkFixed variable that removes or recodes this value 50 into the value 5. The way I'm going to do this is first to close the plot builder window. Then I'm going to go to Data and select Recode Variables. And what I'm going to do is first drag over milk. Then I'm going to highlight milk and select Target. And then it's going to ask me to recode milk into something. So I want to recode this variable into milk fixed. Hit OK. So now you see that this changed the notations in this window. Now it says milk into milk fixed. Okay. I'm going to select define recode. So this is sort of the rule for what I want, or how I want to recode this original value variable of milk. So what I can do here is simply type in 50 here and 5 here and select add. So what this is saying is when milk equals 50, change that into 5 for milk fixed. Okay, I'm going to hit OK, hit OK. So I'm going to scroll over all the way to the right here, and you see that there's this new variable milk fixed. And I'm going to scroll down. Actually, let me go find that 50 first. Where was that guy? Okay, row 30. Okay, or subject 30, I should say, patient 30. And I'm going to scroll over to milk fixed. And I notice that when I go to patient 30 and I look at this value, that it's indeed recoded as 5. Now, how do I know that nothing else has changed? Well, I don't really, unless I run some tests, but just as a sanity check, let me compare the first 3 values with the first 3 values for each variable. So the first 3 values for milk are 16, 0, and 4. The first 3 variables for milk's fixed are, the first 3 values, I should say, are 16, 0, and 4. So, you should always check you should always check the composition of your variables after making a change like this. But for this exercise, I'm pretty satisfied that my recoding worked. Moving on to question 8. Question 8 is asking for the mean, the standard deviation, and the median number of hours of sleep in this data set. So that's a lot to ask for, but there's a really handy function in this program that allows us to generate all 3. So what I'm going to do is go to Analysis and then Descriptives, and then drag over Sleep. I'm going to hit Continue. And then I can select what I want, what sort of descriptive variables I want. I'm going to select median and also drag that over. So now, if I hit Run, I'm going to get the mean, the standard deviation, the number of valid records for that variable, and the median for sleep. And indeed, in the console window, we see that the output is 6.97 for mean sleep, standard deviation of 0.7, and the median is 7 hours. The next question is asking us to perform a stratified analysis of mean outlook on life by alcohol consumption. Or said a different way, what's the mean score for outlook on life for each amount of alcohol consumed? The way I'm going to do this is to go to Analysis and then Descriptives. And then I'm going to move sleep back over here because we're not interested in that anymore. And instead select Optimism. And what I'm going to stratify it by is alcohol, because what we want to see is the sort of mean of optimism, or different descriptive values for optimism by level of alcohol intake. So I'm going to drag alcohol to the Stratify By window, click Continue. And I'm pretty happy with this. I don't really need to see standard deviation, but mean and median are good things to look at. So I'm going to keep those and hit Run. Okay. Now I'm going to widen this window a little bit, and I see that for each value of alcohol, the program calculated the mean optimism, the number of optimism records that had that alcohol value as well as the median optimism for that value. And so to get back to the question specifically asks the mean score for those who indicated that they had 5 drinks. So I'm going to go to alcohol 5, mean optimism is 74.5. The next question asks us how many people consider themselves street smart. Now, just faced with that question, you might not know where to begin, but to phrase that a different way, that's like saying, what's the frequency of people who consider themselves street smart? And that sounds a little more statistical. And basically, that gives you a hint that we want to go to analysis and select frequencies. Okay. Then I'm going to move over the isBookSmart variable and hit OK. So this gives me an output that generates frequencies for the different values of isBookSmart. Now, isBookSmart is binary. It's either yes BookSmart or no BookSmart. In the case of no, it means that you're street smart. That's how the question was phrased. And so we see that there are 9 people who consider themselves street smart in this data set, and 40 people who consider themselves book smart in this data set. Just by convention, I should mention that 0 means no and 1 means yes. That is sort of coding convention. The next question asks us to create a box plot for the variable fruit veg, and it asks us what the black dot in the figure represents. Well, first we need to generate the figure, so that's what I'm going to do. As you probably guessed, the way I'm going to do that is by going to Plots, Plot Builder, and then selecting Simple Box Plot and dragging that down here, and then selecting the variable fruit veg right here and dragging that into the variable box, clicking OK. And here we go. Let me expand this a little bit. So here's the box plot. It looks a little trivial by itself. It's not giving you too much information. But the black dot, so what does the black dot represent? It's defined usually in box plots as data points that are either more than 1.5 times the interquartile range. The interquartile range is basically the length of the rectangle. The interquartile range represents everything from the 25th percentile to the 75th percentile of the data. So if you're 1.5 times that range, then you're usually considered an outlier. So I would say that that black dot represents an outlier in our data set. The last question in the exercise asks us to re-examine the relationship of mean outlook on life by alcohol consumption using a group box plot. So I'm going to stay in the plot builder window. The way I'm going to do that is to select group box plot and drag that down. Under variable, I'm going to move optimism. And then under group, I'm going to move alcohol. And the reason I'm going to do that is because I want to look at the values for optimism for each different alcohol group. All right. So then I'm going to hit OK. First, I might need to delete the simple box plot from before. And then I see this box plot that is stratified by all the different values for alcohol in the data set. And if there was some sort of trend, let's say between optimism and alcohol, if you drank more, maybe you were more or less optimistic about your outlook on life, you would see this box plot, this visual would show you that. But in this figure, we don't really see any sort of trend like that. But it's just a nice way. It's another way of visualizing that text-heavy data that we were looking at before. So that concludes the exercise. One last note I want to make is that there were a lot of different ways you could have approached these problems. And you might have found, let's say, the mean or the median for a variable in a different way than I showed in this video or that I wrote in the solutions. And that's absolutely fine. There are many different ways of arriving at the answer. This is just one example or one suggestion of how to do that. And that concludes this first R video module.